on a bit late this morning, but we are here. Okay, interesting. So this actually, we have parameters that seem to solve breakout. Expensive solve, but it is a solve. And where's our Pareto front? Right here. This is not terrible right here. But we know that we can solve this like this fast. So I think what we're going to do... Hey, welcome. Not in California, if that's what you're asking. We'll be over the summer. I think what we're going to do is we're going to spend a good chunk of time today just really trying to understand some of the quirks with sweeps and figuring out some fixes. Yeah, let's do that. This. So here's Spencer's breakout. And it looks like, oh, this is a new sweep, and he's got... no, you see his new sweep here has the same issue. So we're able to get good stuff too, but he's, yeah, his old sweep, not so much. Maybe it's this one. Yes, so right here, this experiment, I wanted to check these parameters versus what we have now. Okay, so this is a 1024N run. With a very high batch. Makes sense. Entropy. Lowish entropy. A very weird lambda. Not that weird, I guess. Gamma. Actually, this is not too bad. It's a little odd for breakout because you'd expect these to be higher. But, I mean, I could see it. And this learning rate. Low max gradient norm. And then a very low value function coefficient. And 4 update epochs. We get the mini batch size, very low mini batch size. And I believe this is on true as well. $150 million total time steps. This is supposed to work in like 5 minutes, I believe. Okay. And in the meantime, I want to look at the plots for this. Okay, so in particular, the value loss here is very high. This is essentially no value function. So what happens to GAE with no value function? Should reduce to something, right? Going to be a great Saturday? I hope so. I'd really like to get some good progress in on this. Okay, so here is the advantage formula, right? Wait, hang on. Yeah, this is it, right? So if both of these are set to a constant, then this essentially reduces to discounted rewards, right? And let's see how ours. Okay, so this is our curve here. We're at 80 mil. Yeah. And yeah, we get the same exploding value loss. So these parameters do somehow work. Possibly a bit unstable, right? We'll see if it actually solves fully, but these do work. Policy loss spike. I'm trying to think why having a value baseline would actually hurt learning. Hey, welcome. Mind you, this doesn't look like it perfectly reproduces the original, but there's a lot of variance in breakout. So I'm pretty happy with this overall, especially given this is a 5-minute run. $7.17. Yeah, so you can see it's still going up here. Now the question is, why does this happen? Do I need to look at my JE implementation? So if I set this to 0.5, right, it'll break it. We'll just compare. And then we'll look at JE in the meantime. So this gets called from here, and it gets called on Dunn's values rewards gamma lambda. Okay? This is our implementation. Where do they define delta V's? Is this the case? Hang on. I didn't think that's how it worked. Let me look at theirs. PPO Atari. So this is the original CleanRL implementation. So they say delta is rewards plus gamma, next values, times next non-term, okay, minus values. So this is, they have this, right? Yeah, so they do this explicitly, and then, I mean, these terms cancel, but they explicitly do this, and then advantages of t is equal to delta plus gamma. It's not terminal. The one question is, I am missing the last value. If not done. Oh, hang on. Is this similar performance? Wait. Now I'm confused. Look, this is actually a very similar curve, right? Very similar curve. How's the value function? Oh, but the value loss is still up here. Why would the value loss still be up there? Are our rewards not well scaled? Ew. 7 minus. Possibly the rewards just aren't normalized. Brick index. Breakout score. 7 points max. Let me see, so -3 times brick index probably this goes to 0. Yeah, so over 7. Something didn't work here because these numbers should no longer be the same, right? Unless maybe it just hasn't hit anything in the second row yet. That's weird. No, those definitely shouldn't match. Ah, there we go. So this will change the hyperparameters, obviously, that are required, but I just want to see if this does anything with the value function. Also, do we have reward clipping? Or did they make it a wrapper? Yeah, they do make it a wrapper. Reward clipping is just, any reward above 1 goes to 1, any reward less than -1 goes to -1, clip the reward. So they do have reward clipping, and then clip a reward env. I think they do this from SP3. But let's see if it actually does much. They do. Wait, clip by its sign. Oh. It literally converts it to 0. Okay. Interesting. Interesting, the curve looks more stable. Maybe that's just me. Why do you not use... I have Super Maven for single line autocompletes. I mean, they don't really do anything for me. I don't use AI to write full blocks of code. It just writes bad code. I use Super Maven for single line completes, so it's basically just a typing buff more than anything. That's generally what I recommend as well. AI is not better than... Yeah, exactly. I mean, the researchers saying that it's so good for writing code. I've read their code. They don't know how to code. Plain and simple. The vast majority of research code is just awful. Like, truly, truly awful. Like, I don't even know how you warp your head around writing code that bad level of awful. So the value loss should be something here, right? What's the value loss? Oh, look at that. High-level program, yep, has ruined a lot. I agree. That's why so much of the PufferLib code base is in C. It's honestly just super chill and easy. Okay, interestingly, looks like the policy... our policy loss is still good. It's just the old bar. Everything else roughly matches. I mean, the score is like a little bit worse, but again, we didn't retune the hyperparameters or anything. We could also try clipping, which probably would be closer to the original. We'll try clipping next. Okay, so here we have this one. Okay. And actually, there's no negative in here. Do it like this. We'll see with clipping. Actually, clipping makes sense for this game. Potentially. Makes the value function way easier to learn. Oh yeah. And keep in mind, we didn't even retune hyperparameters or anything. How's the value function learning is my question. Oh, 3. Okay. But that's on larger scale rewards than before, so it's very easy for it to learn. So we should probably just add reward clipping to the PPO implementation instead of the env. See if this is stable or not. Oh yeah. Hmm. Well, that's nutty. That's just the reward clipping, lack of reward clipping screwing you. Okay. So we can actually do this in probably 4 minutes now. From Dr. Wang's. Oh, is this Lillian Wang? Wasn't she, oh, okay, she joined She joined Mira's thing. Was at OpenAI and joined Mira's thing, it looks like, right? Oh, co-founder. Cool. Yeah, she has a nice blog. I think this is... likes to write a lot. Not too much, only a few of them a year. It's cool. Was she at OpenAI here? I forget. She just updated this like several times. That's funny. We use PPO for pretty much everything. Honestly, I should read this. But I'm pretty sure PPO just generally does the best overall. Well, the thing is that, like, if you understand what PPO does, it's even simpler than it looks at first glance. Look how stable this is. 863. So now I'm going to try this without annealing. I think this will break it. Actually, this would make a nice post. Yes, the math in RL is pretty simple. In fact, the whole algorithm, like the big term cancels out if pi new is equal to pi old. So you can actually see it's literally just a clipping term. if the defined... It's literally like, it's the simplest thing possible. You get a reward, right, that can be some number, you clip it from -1 to 1. That's it. Here we go. What if the probability for clipping... No, there's no probability or involved in anything. It's literally, it's just, you take the reward that comes out of the environment, whatever it is, and you just, if it's 0, it's 0. If it's... well, to be fair, the way that they do it in SP3 only works because they're arcade games that only return integers, but you just take the reward, and if it's greater than 1, you set it to 1. If it's less than -1, you set it to -1. That's it. I don't know, this guy... I don't know if this guy's a new follower or just a bot. That looks like bot. Yeah. No, like, you have to realize, a lot of the stuff in RL, the math isn't complicated, okay? The thing that makes it hard is it's a really heavily experimental, empirical science that requires a lot of engineering. That's the hard part. There's no fancy math anywhere. I can guarantee you there isn't, because I'm doing this stuff and I don't know the fancy math. Alright? Oh, look at that. That's a nice surprise. This works without annealing? This works without annealing. Lovely. It's a lot less stable, but I think we can still tune this with and without annealing now. And this will be a pretty quick job. I've liked your tweet. Yeah, thanks. Annealing in RL? Okay, another really simple thing. You take so you're going to train it for a certain number of steps, right? You're going to train it for 100 million steps, okay? You just take, what's the term? I think you just multiply the learning rate by 1 minus 1 over the current step over the total number of steps. So you just take a line and you multiply, a line by your learning value. So it decays to 0 by the time the run is over. That's it. These techniques are all like one line middle school math. We don't have fancy things. And we hit 1.7K stars. Making undergrad student come in. He didn't get his objective done. Brutal. I pretty much never went into anywhere, like in undergrad or today. Like, the thing is, though, I literally, okay, here's a fun story. So I missed having lunch with Andrew Ng because I was doing research, and they sent the notification like in the morning that, oh yeah, we have a lunch today, and I was doing research until like 4 in the morning, so I slept until the afternoon. I mean, I got stuff done in undergrad. It was like absolutely horribly unhealthy. I'm pretty sure combined I had more like Monster Energy and like whiskey than I had actual water. But I got stuff done. He's a professor at Stanford, man. Andrew Ng, NG. No, not Yang. Well, this is pretty good. Can we just YOLO something real quick? Let me just YOLO something real quick. Top guys. And isn't Andrew Yang the politician? Andrew Ng is like one of the older ML people. I think he like one of the first papers I read of his that I thought was really cool is he was one of the first people to just go buy a whole bunch of NVIDIA GPUs, wire them up, and train big neural nets. So that was cool. I remember I was in high school when that research was new. I don't know. I emailed him about working in his lab in high school. He didn't reply, but Feifei did. So I ended up working in Feifei's lab. in high school. So I was doing like various computer vision things. I don't think the YOLO run is gonna do it. We'll see. Maybe. Maybe it's just the genius, hyperparameter intuition. We'll see. I doubt it though. I probably have to redo a full tuning run. I think we're also going to take the reward out of the env wrapper. We're going to take the reward out of the environment, and we're going to put it into the algorithm, I think. Yeah. Fortunate. Learning curve is so wonky on these. This. So the guess here was that because it was working better with annealing before, maybe I could just cut the learning rate in half, and that would be good enough. Probably not. I mean, I'll let the full thing run. It's not doing too bad. Manual hyperparameter tuning. Generalized advantage estimation. I think I linked to this thing, right? But if you're looking to get a lot of RL information pretty darn quick, we have the quick start guide on the blog, just on puffer.ai. It's a pretty quick read, and it links all the papers. And this is it. Okay, so it ends up at about the same spot. So not terrible. Probably better with a kneeling. I wonder about Pong. Pong should have a kneeling as well. Where is this guy? We'll leave this one for now. Okay, so this is something we can do now. Let's go mess with the environment, because we don't want to actually clip. Clipping, so I'm clipping in the end now, but I actually don't want to do that. So I'm going to move it into the environment, and then we're going to rerun it just to make sure it works. And then I think we should be good. I mean, we have all these graphs. The green one is the reward clipped one. You can see, though, there's not a huge gap with the other ones. Obviously, it's going to be smoother with annealing. Isn't it just outputting 1 or 2? The value function. Value function's continuous. It's trying to predict the reward. The rewarded breakout is from 0 to 7. So if you get a 7 reward and you predict 0, then you get a squared error of 49. So that's nice though. That means that we can run our sweeps way faster. Was that now I did it in the environment to begin with, but I think we're just gonna add it to clean PufferLib for now. See how that goes. Good time to remind folks to start the puffer. Really helps us out. Got to keep up the puffer growth. How do you not have a GitHub account? If you do like any code on anything. Don't you guys have to write a little bit of code in EE once in a while? There we go. I write code. Then how do you not have a GitHub account? Like what? That's crazy. All right, so this is nice and consistent, right? Looking at how rewards are being set. +1. It's clipped. It's just clipped at the moment. I tried normalizing over 7. It did a little worse. Possibly you just retune hyperparameters and that could do better. But the clipping one is very effective. I mean, for that game, it makes sense, right? Like, you're just trying to break the bricks, and it makes it really easy to learn the value function. So that's probably why this is such a strong baseline. Yeah, there are obviously cases in which you're going to need to have it not just be clipped, in which case you should do some better normalization. But this is pretty decent. Let's add reward clipping. And this doesn't mess with episode return. Perfect. Okay, so we can now keep this. This is good. Mohawk can't. No, I don't know him. Okay. Did you manage to solve it? Oh, I used your old optimal parameters, Spencer. So here, we have a few points of data here. But I set the value function, I set the VF coefficient back up to 0.5. So I tested all these things, and that wasn't it. Annealing, I got it to mostly work with or without annealing. It was really the reward scale was the issue. So here's the sweep. The solve time is like 4 minutes with those parameters. Now, we haven't run the sweep with reward clipping because I just found that out, but this is what protein does with the old parameters where it takes forever to solve. So you can see it doesn't take very many experiments for it to figure out a high scoring solve. Now it runs it for very long here. If we check the Pareto front, yeah, it's doing crazy things with gamma as well. If we check the, yeah, it's one update epoch. If we check the Pareto front, like 1300-ish, it looks like. But this is, again, without the clipping or anything. So now what we can do is we can rerun this. We can rerun this sweep. In fact, I may as well just put that on in the background, right? Dev symbol. Why is it on dev symbol? Oh, I forgot that I did that. Probably just merge these up. This looks good. Okay, so this will now run. 2-minute run, perfect. So now we've actually gotten this back to a point where it will run in a reasonable amount of time for our sweeps. As Pong and Breakout. We obviously want to start running this on way more environments though. I got box 4 back as well, so I can plug that in today. Well, so nothing wrong with JE implementation. What do we do next? What's a good environment? If those new changes are in dev. Yeah, I didn't actually have to change the breakout file at all, so you can just PR that. And yeah, the continuous versus discrete would be a big thing. I also just added the latest sweep algorithm to dev. It's simpler, and you have to be a little careful. If you set the total time steps max too high, it will push up too high. So you'd be a little careful with that. But it's like way more stable than the more complicated one. So I'm trying to think which one of these we should do now. Maybe snake or rware. Did I run this on the wrong machine? I think I did. Hang on. I'm confused. How did I manage to do that? running. I don't know what I was running, but I'm running something. Clipping changes are not needed. I added it into clean RL, yes. I just added it to the demo file. I think that's better because we should actually have something, we should have some sort of test, right, to make sure that we can handle variable rewards, even if it's just by clipping, so that we don't get screwed on that by like forgetting any sort of normalization. So breakout will be a good check for that. Score is snake link. Perfect. Snake, RNN is recurrent. This doesn't have a policy name. $1.3 million SPS, by the way. That's something. Interesting, score goes back down. $200 million steps. See what these guys do. Uh-oh, is it stuck? Might be stuck. Something is screwy here. So we'll have to figure that. See what the policy looks like. Ah, right, there isn't a simple amount. This E3B thing is obnoxious. I think it's a bad method, but we will see. I don't know if you should. We're playing with it for other purposes, but I don't think it's likely we'll adopt it into Puffer at all. It seems to me that just all like the exploration lit in RL sucks, and none of it works. And all it does is slow your code down a bunch. I mean, it's like, that's kind of how it was, frankly. That's kind of how it was a while ago. Like in 2018, it was kind of not a promising area. And it seems like it's pretty much stayed the same. It's just not a particularly promising area. And a lot of the research doesn't make much sense. Okay, so these are fine, but you can see they're biased to the left here. We'll figure that out. We should probably have like a single agent snake version of this as well, huh? Question mark? What? That looks like a CUDA screw up, right? Equivalent. No, it's equivalent to the reward. You're not clipping the return, you're clipping the reward. Is this actually an issue? Hang on. Something is screwy. Oh, yeah, that's totally broken. That's broken my terminal. Nine. Okay, how is the max observation 9? D. Snake colors. What? plus 4. Ew. Yeah, that's gonna break it, huh? Well, we'll do this for now. Oops. How? Come on, how? Oh, hold on. I am dumb. Yeah, this is 7. Alright. I was off by 2 error. It's a new one. Okay. Damn it, this is why I have to keep Restream open, because I can't delete the damn messages if I don't have it open. It should show you the history, but it doesn't. This is irritating. BB thing is so incredibly fucking obnoxious. at all this stuff that you have to patch. Crazy. Do some experiments. That's insanely obnoxious. That it adds shit to the policy like that. Just gonna do this for now. And we'll see how this goes. Okay. And now we can actually see perfect. 200 mil. We want 5E7, 2E8, 1E8. Ah, there we go. And I don't think we need anything else. It's decent enough. Steps. Great. So I'm gonna go get lunch, and then I'm gonna be back working on getting this up and running on more ends. We really want this to be to the point that we can just crank out experiments automatically. I may or may not go also install the new machine while I'm there, just so we have one extra to be able to run stuff on. In the event, thanks folks. If you want to check out the project, puffer.ai, start on GitHub, join the Discord, follow on X, all that good stuff. And I'll be back in a bit.